Interpolation is a method for constructing new data points within the ranges of a discrete set of data points that we have obtained through surveys and experiments. Here, we implement the Lagrange's formula of interpolation, and the formula is here on the right side of the screen. I have 5 points of observation: x1, x2, x3, x4 and x5, and 5 observed values which I represent as f of x1, f of x2, f of x3, f of x4 and f of x5. Here on the left side of the screen you can see the editor window, and x I have defined as a variable which stores the point of observation. F is the array for observed values. xv is the value at which we have to find the value of f, and for this we will use interpolation. The final output will be fxv. Here, as you can see, line number 9. SER is an intermediate variable that we are going to evaluate and update during our execution. Now let us look at the formula. In every term, you will find that we have calculated the differences between the values of x and divided them. Then we have multiplied this product with the value f. So here, line number 4, m is the number of elements in x. This should be the same as the number of elements in f. So I have 1, 2, 3, 4, 5 terms in my formula. So I can use a loop which runs from 1 to m and calculates this term one by one. So this is my ith term. I will specify a comment. Next is, if we observe this very term, what we will observe is, in the numerator, xv is a constant occurrence. In the denominator, the ith term of x is a repeated occurrence. So I build another loop which varies the term after the minus sign in every difference. Further, what we will notice is, in the ith term does not appear anywhere in the numerator. Likewise, the ith term does not appear anywhere after the minus sign. So I can use a condition that if the index of the inner loop j becomes equal to I, then we are not to take any difference, and if they are unequal, then we should take difference. Observing and identifying patterns is an important aspect of working with loops. The third thing that we should observe is that when we evaluate a difference, divide them, we multiply it with the next set. So SER is the intermediate term that I will update in every run of the loop with itself. When we take the difference, we multiply SER with a new term. When we don't take the difference, we multiply it by 1. So the new term that we are supposed to make will be in the numerator xv minus the jth element of x, and in the denominator it will be the ith element of x minus jth element of x. Please take your time and understand this loop properly. What we are going to obtain at the end of the execution of this entire loop will be 5 terms which are the products of the corresponding divided differences. So here, when j is 1, I is 1, we have the first term. So j will run from 1 to 5. When it encounters this condition, when I and j are equal, that is when both of them are 1, SER will remain 1. SER has been initialized with 1s, so SER will remain 1. Next time when j updates, so I and j will not remain equal, so we will be multiplying SER, that is 1, with xv minus second element of x divided by the ith element, I remains 1, minus the second element of x. Then next time when j becomes 3, my SER contains this much. So next time I will be multiplying this much. Next time this much. People who have worked with other programming languages like C will find loops very convenient. For the others, it will definitely take a little bit effort, but MATLAB, being a very easy to learn programming language, you will find it very intuitive and easy to understand. Here, line number 18, we have 5 terms in SER and 5 terms in fx. So here I will multiply element by element the terms in these two arrays, and for this I use the dot asterisk operator. Now we have made our script. We will save it. I call my script LGR. Now we will create some data to work with. I have the length of a pet fish measured for 5 consecutive weeks. The length is in centimeters. The week numbers become our observation points. And the observed lengths become our array F. So in the second week, it was of 6 centimeters. In the third week, 15 centimeters. Fourth week, 20 centimeters. Fifth week, 22 centimeters. Sixth week, 23 centimeters. Next, I will specify my xv as the point at which I wish to calculate our length. So let it make as 4.2. Now we have the script ready. Hopefully we will not have any mistakes. In case we have mistakes, we will correct them. When you are learning something, please be bold enough to make mistakes. Without mistakes, if you expect everything to be correct in the very first time, you will lose a very important part of learning. Let us take a look at the workspace. We have xv as we had created, and we have fxv, that is the value that has been made. Okay, this is one point. fxv is the product of the terms generated in ser and fx. So it is still an array, but what we need is one term. So this summation is what we had forgot. So I will include it in this very line. I will save it and then run it again. Okay, I will clear my fxv from the workspace. I will run it again. Now fxv is the length at 4.2 value for week. So it is 20.5904, which seems to be very reasonable, as in week number 4 it was 20 centimeters. This is how we build functions and use them in different numerical computations.